So this is not necessarily going to be like an entire chapter or anything. So just a quick note, before you go through this chapter, please remember to like just download this PDF file. So yeah, this here is in the course because obviously when you're going to be working on different shapes, there are certain things that you need to know about those shapes, specifically things like the surface area and the volume and all that stuff. So the one thing to point out is that whenever you're dealing with surface area, you see, we need to clarify surface area, volume, and area in general. So whenever you're dealing with surface area and volume is for 3D shapes. You see, when you think of surface area, just think of where you would paint if you had to paint the sketch. That's the big idea with surface area. It works with 3D shapes only, and then think of where you would paint if you had to paint the sketch. So with a sketch like this one, right, automatically what you want to take note of is that you have this circle here. This is like a cone. So if you had to paint this, you would paint the circle up here. Okay, that looks better. And you would then paint all the way around the shape there. So clearly here, your surface area, this is likely one of those formulas that you'll always be given. Now the S here refers to like the slanted height, of which your slanted height here is basically this value over here, you see, because you have a perpendicular height here, and then you have radius. Like that, you have your slanted height, your height, and your radius. That's what this S will be. The S here is for slanted height. The radius is obviously, the R is for radius, going on and on and on and on and on. So that's plain and straightforward. That's for surface area. Now for the volume of the cone, clearly, I mean, that one is also quite straightforward. You just have your formula here. And the one thing I want to emphasize with this tiny lesson is that your formulas you will be given. Sometimes what they'll do is they'll give you multiple ones, and then you just have to pick which one is for which shape and stuff like that. So these formulas, you rarely ever have to cram them, or rather don't cram them, just be able to recognize them. But then depending on how you feel, you can always go into the exam knowing what they look like, because they are genuinely not difficult to remember. Now the key thing to also remember is it doesn't matter if your cone looks like this or if it looks like this. I know it kind of sounds dumb, but you never know. You never know. Trying to accommodate everybody here. And then the other thing to take note of is, remember, if you have R and what you call, if you have H and R, just remember that if you don't have S, you see, you would just be able to work it out using Pythagoras, you see, because remember here, S squared is equal to H squared plus R squared, you see, because of Pythagoras theorem. So for some odd reason, if you did not have this value for S there, we know that you would just be able to work it out by using Pythagoras theorem, you see. So don't forget stuff like that, because they are always super useful. So here we've just been discussing a cone. I think in the next few clips we're just going to be discussing the other shapes, and you can see they are tiny tutorials. They're not long, they're not lengthy, nothing crazy. So obviously with a 3D shape here, they cannot necessarily ask you for area. They can only ask for surface area. And then volume can also only be asked when you're dealing with a 3D shape. There we go. Volume can only be asked if you're working with a 3D shape. So let's move on to other shapes. And yeah, let's keep it moving. So here they can refer to this as a cone, or they can also refer to this as a right cylinder cone. So that's what you want to keep in mind over there. So let's move on to the other shapes.